This is Unit 1/2. In this unit, we'll apply the linear expression in real life to make equations and use calculators to solve that. This is question 1. This is a question that we solve by looking at the graph. When I look at the graph, it's a graph that how much it costs compared to distance of the car rental. And let's say, how long does it cost for me to drive 500 kilometers? So to do this, we should draw a line. We draw a line to 500, about 500, and it looks like it's about $120. So the answer of the A will be $120. In case of B, it asks how much we can drive when I can pay $80, $100, and $75. And I'll just also draw lines for this. Like here I drew the line. And when it's 80, it's about 200. So once 80 is 200 kilometers. And now it's 100. When it's 100, it's about 300 and 400, so I'll say 350 kilometers. And when it's 75, which is this green line, it's just a bit less than 200 kilometers, so it will be 150 kilometers. And this time, we didn't make the equation, but we solved it by just looking at the graph. This is question 2. In this question, it asks to create equation for the question 1, and to solve the questions in question 1 using those equations. So first, we should make the equation. Basically, the linear expression is in form y equal mx plus c. M was the slope, and the c was the y-intercept. Right here, the y-intercept is 50. We can see this pretty easily. And now, we should just find out the slope. We should just find the run and the rise. So the run was how the x changed, and rise was how the y changed. So we'll go to graph, and we should draw the triangle where the integer is. Like this 50, and connect these two. And then this will be the triangle. Right here, the x moved by 200 when you look at the graph. And this one box is 10, this moved by 30 for the rise. So the slope is, getting zeros out, 3 over 20. And then I'll just write the equation again. Then it will be y equals 3 over 20x plus 50. And for A, it asks us how much does it cost to ride 500 kilometers. And right here, the x will be the distance and y will be the cost. So let's calculate this. 320 multiplied by 500 plus 50. And this equals 125. At the first, we said that it was $150, not $125. But right here it says that it's 125. So like this, what we did by our eyes and what we did by equation has a huge difference. For B, it asks how much we can go if I pay $80, $100, and $75. But to do this, I think it'll be easier to just change the equation. So then will be y equals 3 over 20x plus 50, and then the 50 will go over. Then y minus 50 equals 3 over 20x. So right here, because y is the cost, we'll put each of those costs in this y. Then 80 will equal 30, 100 will equal 50, and 75 will equal 25. And to get x, we should multiply both sides with 20 over 3. Right here, we should multiply 20 over 3 to each of these numbers to find it out. And if we calculate this, this will be simplifying those two, so it will be 200. And right here, it will be 1000 over 3. Right here, it will be 500 over 3. To do 1000 divided by 3, it will be 333.333 and just go on. And to do 500 over 3, it will be 166.6666, and this will also go on. And right here, remember what was the first answer? So we guessed $200 for 80, 20 kilometers for 80, 350 kilometers for 100, and 150 kilometers for 75. But when we look this out, we can check out that there's a difference by something that we calculated with the equation. The 200 kilometer was correct, but this was 333, and this was 166.666. Right here, we have a huge difference between the number that we got by the graph and the equation. So if the question asks what's more accurate, of course the equation is way more accurate because we did the first one just by looking by our eyes. So in case of B, when the question asks what's more accurate, you can just answer it that the equation is more accurate. This is question 3. Right here, there's a milk carton that's 1890 milliliters full. But every minute, 5 milliliter is leaking. So we should make the equation using this and draw the graph. Before doing that, I'll draw the table. When 0 minutes pass, there will be 1890 milk left. When 1 minute passes, there will be 1,885 milk left. 2 minutes pass, 80 milliliters of milk left. 3 minutes pass, 75 milliliters of milk left. When the time slows, the amount of milk left also changes, so we'll put times x and milk left is in y. And to find out the equation, we should find the m, which is the slope, and z, which is the y-intercept. So the slope is run under rise, so the run is how the x changed, and rise is how the y changed. When x changes by 1 like this, the y changes by minus 5. So the slope will be minus 5 right here. Like this, we have found the slope. And right now, we should find this y-intercept, which is c. And y-intercept is a point that x is 0. So then, when x is 0, then y was 1890, so the y-intercept was 1890. And then let's write the equation down. Y equals minus 5x plus 1890. This is the equation of the milk leaking at this situation. And now, we should draw the graph. To draw the graph, we need the x-intercept, y-intercept, and slope. We can only draw it using slope and y-intercept or x-intercept, but we'll just get all 3 of them. So we need to get the x-intercept like this because we can only get slope and y. Then 0 equals minus 5x plus 1890. So 5x equals 1890. Then the x will be 378. And now let's draw the graph. X is 378. And y is 1890. And if we just connect these two using one single line, this will be the graph of this equation. And B asks, how long should the time pass for the milk left for 1 liter? Until now we use milliliter, but because these liters change the unit first. Because 1 liter is 1,000 milliliters, we can change it like that. And then it will be 1000 equals minus 5x plus 1890. The 5x go over, 1000 go over, then 5x equals 1890 minus 1000, so it will be 890. And x equals 178, which is almost 3 hours. Right here in question 3, if it's just too hard to write the question for you guys, maybe just try to draw this table. Then it will be way more easier to find out the equation. This is question 4. The graph at the right shows the charge of the banquet compared to the number of people that attend the banquet. And the A asks, what does the coordinate 160, 5,700 shows? So when we just look at the graph, when 50 people attended the banquet, then they charge about $2,000. And about 100 people attended the banquet, they charge about $4,000. And the number that we're given, 160, 5,700, means that when there are 160 people attended, they will cost $5,700. And for B, it asks how much does it cost if there are 200 people in the banquet. So if it's just gone until 200 and this point, and we just drag it down, we can check that it will pay about $7,000. And now go for C. This asks us to draw the equation for this graph. And to get the equation, it will be y equals mx plus c. Right here, the m is the slope, the c is the y-intercept. And so the number of people are x, and the cost will be y. So the c is a y-intercept, so it will be 500. So the c is 500. And we should find the m, which is the slope. To find the slope, we should just draw a triangle that has each integer as a corner. So like this, we'll put one corner here, one corner, which is your color 500, and this will be another corner, which will be 200, 7,000. And so once the x is 0 and move by 200, the x change by 200, so that's a run. And 500 to 7,000, so the rise will be 6,500. And 2 of the zeros go away, then it will be 65 over 2. Slope of it, and 2 over 65x plus 500. This is the equation. And so right here, x are people, and the cost is y. And D asks, using the equation to find out how much people have attended if there are $3,100, $4,400, and $5,000. So because the cost is y, we'll just manipulate these equations just a bit. Y equals 2 over 65x plus 500, but so the 500 will go over. Y minus 500 equals 65 over 2x. And again, to make x as alone, we'll multiply 2 over 65 to both sides. Then it will be 3,100 minus 500 is 2,600. And multiply 265 like that. And 4,400 minus, it will be 3,900. And it will be again 2 over 65 multiplied. 5,000 minus 500, 4,500 multiplied by 2 over 65. And these will each get 80, 120, and 138 as an answer for it. So also the graph should be in broken line. Because there can be like 1.3 per people or person. So the graph should be broken line, not full line. This is question 5. When in the internet, Max have found that 1 US gallon is 3.785 liters. And question A asks us to draw the graph. To draw the graph, we should find the x and y. So let's just write it out. Then 1 gallon equals 3.785 liters. So right here we'll put gallon as an x and liter as an y. Right here we'll point the graph, but 1 to 3.1785 is a bit harder. We'll change it to 10 to 37.85, which is basically the same. So right here will be the 10. And 3.785 will be about here. And if we connect the base and those like the point like that, that'll be the graph of this equation. And the B is we should look at the graph and solve it. So it asks us how much liter is a 6 gallon. So we must find this out. So right here, we should find the x and draw the line straight up here. I'm trying to draw it straight. And like I said, it will be about here. And if we just connect it from the y-axis, it'll be like this. So I guess about 23 liters. And lastly, at C, it again is asked how much is 14 liters equal to gallon. So again, we should draw this. So 14 will be, this is 5, so it will be about here. And then we should draw the line straight down. So, because this point right here is 5, then this will be about 4, I guess. So 14 liter equals to 4 gallon. This is question 6. Melanie is driving from Ajax to Ottawa. Ajax, she departed from 250 from Ajax. And currently there are 35 liters of gas in her tank. And the low fuel gas light comes on when she has 9 liters left in her gas tank. Also, she can drive 9.5 liters by 100 kilometers, and she's driving 100 kilometers per hour. Let's just write this down. Ajax to Ottawa, and then she departed from Ajax at 2:15. And also, there is 35 liters of gas left in her tank. So when there are 9 liters left, the low fuel light will come on. So this is when she should refill her gas. And there are a few more conditions. She's driving at 100 kilometers per hour of speed, and then she has 9.5 liters, and then she can drive 100 kilometers. And here's 100 here and 100 here. These two are definitely related to each other. And right here, we should find out when will the low fuel light will come on. So then 35 minus 9 is 26. So that will be 1 choose 26 liters of gas. And 26 divided by 9.5 equals 2.768. And then this 2.7368 means the time that it takes for her to use those 26 liters. So 9.5 liter equals 100 kilometers, and that equals 1 hour. So then, which is 19 liters, you can drive 200 kilometers, and that will take 2 hours. And then, there are 7 liters left, and that will equal 0.76368 hours. And that will drive a certain distance, right here. And then, that 0.7368 hour, we can just write that in a minute. So she started the part at 2:15. First we'll add 2 hours from here, and some minute. And right here we'll use proportional expression to solve this. 1 to 60 equals 0.7368 to something minutes. So we'll do 30, 60 and that, and 1 and x. Then it will be x equals, we'll just calculator here, 0.7368 multiplied by 60. And this equals 44.208. Right here, the x is 44.208 minutes. And then this will be 44.208. When we add all of those together, this will be 459.248 minutes. So this is when her low fuel light will come on. So this question is a bit hard, but you can just solve it when you just try slowly. This is question 7. Hank earns basic salary of $280 and 4% of commission. Question A asks us, so how much commission should he sell to earn $900 of salary? And question B asks to make the equation and verify it. So because we need the equation to solve question A, we'll do B first instead of doing A. So we'll do the B, right here B. So Y will be the weekly salary. Y equals $280 plus 0.04x. And right here, X will be the commission. And then let's try to solve A. He should earn $900, we should put Y as 900 equals 280 plus 0.04x. And then because we should get x, the 280 will go over. 900 minus 280 equals 0.04x. And we'll divide the whole side with 0.04. Now let's use a calculator right here. Fraction 900 minus 280 divided by 0.04. And it will be 15,500. So that will be the answer for question 7. This is question 8. The company name Perfect Paving Company charges $10 per square foot to install the paving stones, and also they have $40 of delivery fee. And A asked, determine the greatest area that enter can pay for $3,500. So let's write it out. $3,500, but we should minus 40, which is the delivery fee, and it will be $34.60. And then we should divide both sides with 10. Then it will be 346. So square feet. So this is how much that he can pave. We solved A like this, and let's go for B. Andrew needs to include 5 cubic yards of sand. So when we pave in front of the garage, those sands are some things that go between the paving stones. So this is what B is asking. So 5 cubic yards of sand are needed, but it costs $15 per cubic yard. So it asks us how much of the area will be reduced of the paving. So we need $75 to buy those cubic yards of sand. But instead of just minusing that from 3,460 and calculating it, let's just divide it by 10 and minus from square feet. So because it usually to be 346, right, because we need more money for the sand, that reduce. So right here, let's divide it with 10. So 75 divided by 10 equals 7.5. And right here, the 10 is the price of the paving. And this means that this is how much the area decreased for the paving. Because he can usually do this much of paving instead of those sands. So right here, the answer for the B will be 7.5 square feet. This is question 9. The Student Athletic School Council has raised $4,000 to buy sports equipment and uniforms. And before doing that, they will put those money in the interest account that gives 3.5% every year. But before we solve this, we should talk about simple interest and compound interest. So let's say that they both invest $1,000 in the accounts. So at the first year, they'll both have $1,000. So in case of simple, they will have 1,000 plus 1,000 multiplied by 0.04. So this will be 1,040 in the second year. And in the third year, it will be 1,040 plus 1,000 multiplied by 0.04. So this will be 1,080. And the last year, it will be 1,080 plus 1,000 multiplied by 0.04. So it will be 1,120. So this is a simple interest. Simple interest gets the interest on the first principal, or the money that we first put in the account. And now let's go to compound interest. And until the second, it's the same. It's 1,000 plus 1,000 multiplied by 0.04. So this will be also 1,040. But from the third year, there is a difference. It will be 1,040 plus 1,040 multiplied by 0.04. And this will be 1081.6. So the simple had the interest on the $1,000, but the compound interest has the interest in the one that's right before, which is $1,040. And this will be 1081.6. Until now, there's no big difference. And let's look at the fourth one. It will be 1081.6 plus 1081.6 multiplied by 0.04. And it will be 1124.864. And because we only put $1,000 and we only for 4 years, but if we put more money like $1 billion, $10 billion, or if we keep the account a bit longer, there will be a huge difference between those two. And right here, the box right there is the equation for the compound interest. And now let's go to the 9 and solve it. So because this is simple interest, we'll write an equation about it, which first get $4,000 is constant plus 400 multiplied by 0.035x. So that x is the years. Y equals 4,000 plus 140x. And now let's draw the graph using this. Because the number is just too big, we can get x-intercept easily, so let's start with y-intercept. Y-intercept will be 4,000, and then right here, we'll put 4,000, and then we need one more point, so for the other point, we'll put 2 in the x. It will be x, 1x is 2, it will be 4,000 plus 280, so it will be 4,280. So we can find exactly, but here will be 1, here will be 2. And let's guess this is about 40 to 80. And if we draw the line, this will be the graph for this equation. And using the graph, we should determine the value of their investment after 2 years. But because our graph is just a bit too rough, we will just find it out using the equation. It will be 4,280, so will be the answer. And for the C, we should use the equation to determine when their investment is worth $4,385. So it will be equal 4,000 plus 440x, and 140x, 385 equals 140x, then x equals 2.75. So if it's 2.75, it will be 24, and 7.75 will be multiplied by 12, it will be 9. So this will be 9 months, and the answer will be 2 years and 9 months. This is question 10. Mary has a budget of $90 to take her grandmother for a drive. Katie's rent cars for $65 per day, plus $0.12 per kilometer. Determine how far Mary and her grandmother can travel, including the return trip. To solve this question, we should first make the equation out. So, fix her budget is $90, we'll put y as $90. Then 90 equals $65 plus, so per kilometer it was $0.12, so it'll be 0.12x right here. But we should be careful of something right here. Because it's a return trip, not a one-way trip, we should multiply 2 right here. So it'll be 0.24 and 0.12. So 90 right here. If we just calculate this, it will be 90 minus 65 equals 0.24x. And this will be 25 equals 0.24x. And right here, the x equals 104 kilometers. But because this is just one way, we should multiply 2 to make it a return trip. So it'll be 208 kilometers. This is question 11. Cam earns $400 per week plus 2.5% of commission. And now he has been offered another job that pays $700 per week but has no commission. So we should compare these two. And A has to list 3 strategies that you can use. The first is equation, the second one is a table, and the last one possibly is a graph. So we can just write these down. And now let's solve these. What job should Cam take? And because it asked us to justify it, let's just solve it. So I'll use the equation to solve it. Then it'll be 400 plus 0.025x. So this is the commission. And now it's 700. So he will only move his job if he earned more money if he moved his job. So then the 400 goes over down. It becomes minus 400. Then 0.025x equals 300. Then we'll divide both sides with 0.025. So x is smaller than 12,000. So when his commission is smaller than 12,000, he should move his job. And if his commission is higher than 12,000, he shouldn't move his job. This is question 12. At 9 a.m., Chantal starts jogging north at 6 km per hour from the south end of a 21 km trail. And at the same time, Emmett begins cycling south at 15 km per hour from the north end of the same trail. So we should use the graph to determine where they will meet. So before doing that, we should draw a little diagram about it. So here's a trail right here, here's the north, and here's the south. And so the whole trail is 21 km. And at the south, Chantal started jogging at 6 km per hour of speed. And at the north, Emmett departed with 15 km per hour of speed. And then, at some point, they will meet right here. So do you remember DTS? Right, like this. D was the distance, which equals the time TS. And T was SD over S, and S was D over T. And right here, something we can know is that their only thing that we can know is their speed. So the graph that we should draw should be the speed graph. So it should be created of T and D. Let's draw it out. So first look at Chantal. So he went 6 km per hour, so it will be about here. If we just draw a line like this, this will be the graph of Chantal. And in case of Emmett, he goes 15 kilometers per hour. So 1 to 15 equals x to 21. So multiplying the inside and outside, then 15x equals 21 kilometer. So x is 1.4 hour. Because we have the distance equal 21 kilometers, so he'll start here, and maybe this is about somewhere 1.4. And if we connect these two lines, this will be the graph of Emmett. So because the graph that we draw isn't exact, instead of using graph, we're also using equation. So there's a 21 kilometer right here. Chantal started at the north and south, and Emmett departed from the north. And they will meet at some point. So just think about it. When they are meeting at some point, what speed they run, they would have passed same time. Even though Emmett is driving a car and Matt the bicycle, they will still meet at same time and driving same time. So we'll solve the t as a keyword which is same both each other. So for example, with the speed of 6 km per hour, we don't know the distance how much until when, where they meet. So we'll put those distance as an x. And then distance that Emmett went will be 21 minus x. So right here, I'll just write it down. T equals d over s. So in case of Trendle, it will be 6 over 6. So because they're the same, we'll put as an equal. And then Emmett was 21 minus x over 15. Multiplying in diagonal, 6 multiplied by 21 minus x equals 15 multiplied by x. 126 minus 6x equals 15x. The 6x go over it. The 126 equals 21x. Then x is 1 hour. So after 1 hour, as we have looked at the graph, after 1 hour, they won't meet. So because they met at 9, they'll meet at 10. So like this equation is easier to solve. So every time I'll see this question, I'll show you both the equation and the graph to solve it. This is question 13. It asks us to find the x of this equation both using both graph and equation. So in the linear relation or expression 2x minus y equals 6 when y equals 5. So we find out the x when y is 5. So first we'll explain it using the graph. So to draw a graph, we should draw in y equal form. 2x minus 6 equals 3y, dividing both sides with 3. Y equals 2 over 3x minus 2. Right here, the y-intercept is 2. And this is our x-intercept, we'll write down this, we'll find the slope instead. So when x moved by 3, the y moved by 2. So let's just connect these two with a straight line carefully, and it'll be like this. And then it asked us when the y is 5, what's the x? Right here. And again, try carefully. And then we can see that it's somewhere about 11. So we'll just write 11. This time with the equation, not the graph. This will be easier. 2x minus 3y equals 6, and y equals 5. So this y equals 5. Then 2x minus 3y, it used to be y, but because of y should be changed to 5, erase it, and write multiply by 5, and this equals 6. Then 2x equals minus 15 equals 6. And then 2x equals 21, so the x is 10.5. So like this, in the graph we get 11, but in the real equation we got 10.5. So you should always be careful about this. This is question 14. So the card got opened, and there's a darn game. So when they hit the bullseye, you'll receive 75 cents. But when you miss it, you'll charge by 25 cents. And he tried 25 times, and he paid $5.25. Then how much times did he hit the bullseye? This time I'll just solve his equation, not the graph. So this is this and I'll find it lately. So let's just do it right now instead of being late. Then 75 cents. So we put this x, and so he missed a bullseye and he paid 25 cents. We'll put this as a y. So he played 25 games in total. And then he paid $5.25. So let's make the equation sound. X plus y equals 25. And then we should match the units. So because 75 cents is $0.75, 25 cents is $0.25. So the money that he earns will be in plus, and money that he loses will be minus. So right here down there, it's a bit messy because of decimal. We'll multiply 100 to both sides. Then 75x minus 25y equals minus 525. So if we make this number just too big, we'll divide the whole side by 25. And then 3x minus y equals minus 21. And then we'll just bring these two equations to the right. Then x plus y equals 25. And 3x minus 5 equals 21, sorry. And we'll just add these two up. So then this will be 4x plus y minus y 0, 25 minus 21, and this will be 4. So the 4x equals 4. So because x was when he hit the bullseye, he had hit the bullseye one time, one single time. And what we just did is something called system. So we'll learn this later in the book, but if you can't just understand it, you can look at the book or maybe listen to this more. Question 15. Adrian earns 5% commission on her sales up to $25,000, 5.5 to $25,000 to $35,000, 6% of any sales between $35,000 to $45,000, and 7% for $45,000. And first we should draw the graph for this. Right here is his equation, 25,000, then also 5%, 25 to 35,000. This is 5.5%, 35,000 to 45,000. This was 6%. Higher than 45,000, this was 7%. So then, when we draw the graph, just compared to the amount of x, the slope will also change. So right here, I'll draw right now in the graph paper right there. 5% of 25,000 is 1250. So when you didn't sell anything, 0 comes 0 from here. Right here. At 25,000, right here. And 1250, because this is 500, it will be about here. And then we'll connect these two like this. And then this is graph until 25,000. And this one will calculate the 5.5%. So 35,000 multiplied by 0.55. This equals 1925. We'll go to graph and write this down. 35,000. And this will be close to 22,000. So it will be about here. If we connect these two by a line, the slope will change and it will look like this. And then let's do 35,000 to 45,000. So let's calculate in 6%, 0.06, and 2,700. So we'll go to 45,000 somewhere around here. Draw a line straight up from here. 2,700 about here. Connect these two with one line. So you can see the slope is just a bit higher. And right here, because it's 7%, it will be, the slope will again just a bit higher. So right here, in this graph, compared to the X amount, the commission with the Y, the slope also change. So you should always know how to draw this graph also. This is question 16. So right here in the button shop, from 1 to 25 buttons, they cost $1 per button. From 26 to 50 buttons, it costs 0.8 per button. From 50 to 100, it costs 0.6 per button. And over 100, it's 0.2 per button, so the price decreases as it goes. So for draw the graph, we'll draw the table. Until 25, it will be 25 multiplied by 1. So it will be $25. And from 25 to 50, so it's $0.8 per of those. So it will be 25 multiplied by 0.8, which equals 20. And from 51 to 100, this should be 26. From 51 to 100, so it's $0.6 per button, so it'll be 50 multiplied by 0.6, and this equals 30. And finally, over 100, it will go, let's just say until 125, it'll be 25 multiplied by 0.2, which is just $5. And now I just finished the table for each of these areas right here, or regions. Let's find by 50, I should add 25 plus 20, because I also bought 25 in front of it. for this one, I should do 25 plus 20 plus 30. So it'll be $75. And then for over 100, it'll be 25 plus 20 plus 30 plus 5. And this time I'll draw the graph. From 25 as 25, and from 50 as 45, and then we can just ignore 75, and from 100 75, and we connect all of these using the line, and this will be the graph of this question. Like this, question A, we create a table and the graph for it, and question B asks, what should we recommend? Should we compare the cost of 100 and compare 101? What advice or what would we recommend to give someone who needs 100 buttons? And because the button is something that we use, or maybe you can lose it, I guess it will be a better choice to buy a bit higher than 101. Also, it's just way cheaper if it goes 100. And finally, it's question C. So based on those situations, you should write each of those equations for a bit. So these iterations means 20 until 25, until 50, until 100, until 125. So it's basically the equation of the graph. So let's start it. From 1 to 25, we'll write the equation of it. So right here, before that, we'll just write the condition. So here's the n. It's bigger or same than from 1, and smaller and same from 25. But also you should remember that n is always the integer, like this. Okay, and like this. And then from 1 to 25, the C means cost. So the cost equals, because it's just $1 per button, it'll be just n. And now let's go for the next region. When n is between one bigger or same than 26, or smaller or same compared to 50. And then before writing down the equation, let's just think about it. If we have bought 30 buttons, until 25 we'll just count $25. And after that, those 5, which is just 30 minus 25, these 5 will just cost $4, which is 5 multiplied by 0.8. And now let's do it by 40. So then they're $25 until 25. Minusing 25 from 40, it'll be 15. And 15 multiplied by 0.8, that equals $12. So think about that, let's just write it down. Cost equals 25, which is the base price is constant, and plus 0.8. But this time, no matter how much you bought, it'll be n minus 25 multiplied by 0.8. And this time, it's 50 bigger than 50, greater than or same than 51, and smaller or same than 100. So when the first 25 was $25, and then the second $25 and was $20. So then, 51 will write it down. C equals 25 plus 20 and plus, it's 50 until 100, 0.6 multiplied by n minus 50. And let's go for the next one. If it is 101 or more right here, like right here, the C is 25 plus 20, and we just need one more right here, and this will be 50 multiplied by 0.6, and then this is 30. It's very simple. And this time it's also plus 0.2 multiplied by m minus 100. And then this will be the equation for bigger than 101. Like this, 1.2 is just finished. If you liked the video, please press like and subscribe to the channel. Those likes and subscribes will be very helpful for the channel.